Okay, so let's say you need the sine of 40 degrees and you don't have a calculator. What do you do? So first of all, what people even did way before there were calculators, so how we created these things is we would get a protractor and we would create a angle of 40 degrees, a triangle. So here's 180, we'll go to 40, and then just drop down and make our 90 degree. And we can just check with our protractor that this angle over here is 90 degrees, and it is, so we're good. So right here we've created a triangle. This is 40 degrees, and we know that this is a right angle. And we know that the sine ratio is the opposite over the hypotenuse. So what we would do then is grab a ruler and measure first the opposite and then the hypotenuse. So to measure the opposite, I'll just put my ruler right here. You can hopefully see already that the precision here isn't perfect because these lines are a little bit thick, but we can say that this is about 3.5 centimeters. Then we can measure our angle here, our hypotenuse. Get my ruler. Oh, come on. Okay, and I can grab my ruler and measure my hypotenuse, which again, it's a little bit of an estimate, 5.56, let's say 5.6 centimeters. So now that I've measured my two sides, I can find my ratio by just dividing my opposite, which is 3.5 centimeters, over my hypotenuse, which is 5.6 centimeters. Now, again, I'm saying that this is what we did when we didn't have calculators. However, of course, we'll just use our calculator right now. 3.5 divided by 5.6 gives us about 0.625 as our sine of 40 degrees. Now, what happened was people spent tons of time coming up with these being way more precise than we were, going to way more decimals than we've gone to. And then they collected all of those into a list. So if we look here, the sine of 40 degrees that was collected in this list, which is this is actually from NASA. This is a table, and it is every angle here, and then it is the sine of that angle. So we can see right here that the sine of 40 degrees, more precisely, is 0.6428. So that's what people would need to do if they didn't have the calculator that had already collected all those things for them. However, we now are fine. We can just take a calculator, we can take the sine of 40, and it tells us this is the most precise of the three numbers. So we saw that on the table it was 0.6428, and now this one is even more precise, giving us the ratio of the opposite to the hypotenuse for the angle of 40. So really now for any angle you wanted, all you would have to do is go to your calculator, type in sine and the angle, and it will tell you the ratio of the opposite to the hypotenuse. And of course that works for cosine and for really any of the others. Tangents.